Hello and welcome to today's lesson. We're going to be talking about classifying real numbers. So basically all these different types of numbers that you've been working with in your little math career, fractions, decimal, whole numbers, counting numbers, they all have different properties, and as a result, mathematicians have categorized them into different categories. And we're going to go over today what those categories are called and their definitions, and that's something you definitely want to take down in your notes. As always, please make sure that you're not wasting your time watching these videos and that you're taking really good notes so that you have those to refer back to when you need to study this topic or review or when you're trying these problems on your own. I'm so glad that you're joining us today, and let's go ahead and take some notes.
All of the numbers that you have worked with so far in your math career is a type of real number. And when you get into Algebra 2, you look at numbers outside of real numbers. But for now, you just need to worry about these real numbers. And there's different types of real numbers. And both of these charts have the same information. It's just a different way of listing it. So this one shows it to you how they're included in one another. This one just gives it to you in a list. This one gives it to you in words. This one gives it to you in numbers. So just different ways to look at the same information. So within real numbers, all real numbers are either rational numbers or irrational numbers. And rational numbers are any number that can be expressed as the ratio of two integers. So you can write it in fraction form. It might be a decimal, it might be a whole number, but you can write it as a fraction, and that's why all these examples are fractions. An irrational number is a decimal that neither terminates nor repeats. So you have pi. Pi is a never-ending decimal that doesn't repeat. If you work out 2 to the 1/2, or the square root of 2, that's going to be a decimal that never repeats. So sometimes you had to type these into your calculator to see if it's a decimal that never ends or repeats. So within the rational numbers, you can get more specific and have integers. Integers are whole numbers and their opposites. So whole numbers are 0, 1, 2, 3, 4, 5, and then integers include the negatives. So the next more specific is whole numbers, and so that's all of the natural numbers and 0. And so then we have natural numbers are the set of counting numbers, and so how you naturally count. So natural numbers are, you start at 1 and you just go 1, 2, 3, 4, the numbers that you learn in 1st and 2nd and 3rd grade. Those are your natural numbers. When you add 0 to that, that's your whole numbers. When you add negatives to that, that's your integers. When you add fractions and decimals that end or repeat, that's rational numbers. So that's all the vocabulary you need to know for this lesson. So make sure you have that copied down in your notes before you move on. It's just a way to help you remember which types are rational and which types are irrational. So rational, if you think of a rational argument, that's a good argument. It's a fitter argument. And so those are going to be F for fractions, I for integers, T for terminated decimals, terminated means ends, and R repeated decimals. Whereas means not, and so does non. It also, both of those prefixes both mean not. So irrational numbers are your non-perfect squares, your non-terminated decimals, so non-ending decimals, and non-repeated decimals. The last bit of notes is going over whether or not when you're adding, subtracting, multiplying, or dividing rational and irrational numbers, whether or not that system is closed. Closed means that if you take two rational numbers and perform an operation, you end up with a rational number, which the rational number system is closed under addition and multiplication. So that means if you take two rational numbers and add them, your answer will always be rational number. If you take two rational numbers and multiply them, the answer is always going to be a rational number. And so just for an example, if you take 4.35 and add negative 7.24 to that, your answer is going to be negative 2.89. That's still a rational number. And then if you multiply those two fractions, 2/3 over 3/4, that's 14 over 12, which reduces to 1 and 1/6. 1/6 is a repeating fraction. 0.166666666 forever. And so that means this is a rational number also. But the irrational number system is not closed. So you could add two irrational numbers. You could end up with a rational answer or an irrational answer. And the same with multiplication. And there's some examples down here that show you those. So here you're adding two irrational numbers and your answer is 9, a rational number. In the second example, you're multiplying two irrational numbers and you get 10, which is a rational number. And then this last example, if you add these two irrational numbers, your answer still ends up being an irrational number, because when you convert this to a decimal, the decimal just keeps going forever and not repeating. Our first question here wants to know which of the following is an irrational number. Well, remember, irrational numbers are non-ending decimals, non-repeating decimals, or non-perfect roots. And so to find out if 1/5 is a repeating decimal or ending decimal or not, I'm just going to take 1 divided by 5 on my calculator, and that equals 0.2. So that ends. So that's a rational number. So it's not A. The square root of 9 is 3. So that's a rational number. So it's not B. C, 3.8, that's a decimal that ends, so that's an irrational number. And then the square root of 38 is 6.164414, and it keeps going and it never repeats, so that's an irrational number. It doesn't repeat, it doesn't end, so D is your final answer. Which of the following is an irrational number? So we're looking for decimals that end. We're looking for decimals that repeat. So the square root of 29 is 5.38516480713. So you can see it just keeps on going and it doesn't repeat. So that's irrational. So it's not A. Pi, we know, is 3.141592. And the number just keeps going also. Pi by definition is a number that is a decimal that just doesn't repeat and doesn't end. So it's not going to be B. That's irrational. C, when I take the square root of 66 in my calculator, I get 8.12403840, etc. That's a decimal that just keeps on going. There's no repeating. So it's not going to be C because it's irrational. And then when I take the square root of 144, that's 12. That's a whole number. That's a rational number. So that is D. So in this question here, they give us the number pi over 2, or pi halves, and it tells us that that fraction converts to this decimal. And it wants to know which of these subsets does it belong to. So it could belong to 4 of them, it could belong to 1 of them, or something in between. And so I look at this decimal and I see that it doesn't repeat, it doesn't end, it just keeps going. So decimals that don't end, that don't repeat, are irrational numbers. And so if you remember back to our notes, if it's irrational, it can't be any of these other 4. So it's just irrational, so that means D is going to be my final answer. This next one is the same type of question, but instead of giving us one answer, or one number, they give us 5. So I'm just going to look at that first one and see what is that when I convert it to a decimal. So I'm just going to take pi divided by 4 in my calculator to convert it. And when I do that, I get this decimal right here. And you can see that this decimal, it's not repeating, it's not ending, it just keeps going forever with no pattern. So that means that pi over 4 is going to be irrational. I know that pi over 2 is irrational from my last question. And so that means that since 2 of these are irrational, and I don't have the choice of none, that means the rest of these are going to be irrational. You can check them, though, to make sure that they are all non-ending, non-repeating decimals. And then once you know it's rational, you know it can't be any of these other 4. And so once again, that means C is going to be my final answer, rational numbers only. Okay, this next one, they give us one number, 13 times the square root of 50, and want to know, is this an integer of neither rational, irrational, rational, or irrational? So the first thing I'm going to do is I'm just going to put this into my calculator, 13 times the square root of 50, and when I do that, I get 91.9238815554, and it keeps going. So I can see that that is a non-ending, non-terminating decimal. So that means it's going to be an irrational number, which is D. Here it wants to know which of the following statements is true. So we're going to be going back to that last set of notes where we look at, which system was closed, which one wasn't. So if we go back to our notes, the rational number system was closed. The irrational system was not closed. So here it's talking all about irrational. So I'm looking for one that says not closed. And so B says closed. D says closed, so I know it can't be B or D. So I'm just looking at what's the difference between A and C now, because they both say not closed. All right, so I look at it. A talks about it not being closed under multiplication because the product is not always an irrational number. Whereas C says that if the product of two irrational numbers is always a rational number. So for it to not be closed, it cannot always have an irrational number answer. So that means it's going to be A. This question here is asking for a true statement, and it's looking at all rational number systems. And we know from our notes that the rational number system is closed. So that means it can't be C or D because it talks about it not being closed. So I can go ahead and cross those off. And then I look at the differences for A and B. A says it's closed under addition because the sum of two rational numbers is always a rational number, whereas B says it's always an irrational number. For it to be closed, you have to start and end with the same type of number. So you have to start with two rational numbers and end with a rational number. So it's going to make my final answer A. Thank you for joining us today, and I hope you learned something new.